Good morning. Today I'm going to go through examples for how to solve a function machine when the input equals the output. In the first example, you can see that my input is being multiplied by 9. I'm then taking away 24, and then I'm getting my output. So what I'm going to do is I'm going to use this information and construct a equation. Now, if my input was x, I would then multiply it by 9, and then we multiply by 9, we put the 9 in front, so it's 9x, 9 lots of x. Then I'm going to take away 24. And if my input was x, my output must be x. So therefore, whatever I do to this is going to be equal to x. Now I have an equation which I need to solve. So to solve this equation, I'm going to add 24 to both sides. Because I've added 24 to minus 24, these just cancel each other out, and I'm only left with the 9x on the left-hand side. And when I add 24 to x, I get x plus 24. Now to solve this, I need to get all of the x's onto one side. I can't have x's on both sides of an equation. So I'm going to subtract this x from both sides. 9x take away x is 8x, and then I'm left with 24 because x take away x will be 0. So 8 x's, 8 of my inputs is equal to 24. So to find out what one of them is equal to, I just need to divide by 8 on both sides. So therefore x equals 3, and that is your answer. So it's all about making an equation and then solving equation as we've done before. So, second example, I have an input. I divide it by 3, I take away 6, and then I get my output. So let's have a look at what this equation would look like. If my input is x, I then divide it by 3, then I take away 6, and it's equal to the output, but the output is equal to the input. So I put x in and I've got x out. I'm putting x in and I've got x out. So now I need to solve this. Now, I don't like working with fractions necessarily when I'm trying to solve an equation. So the easiest way to get rid of this divide by 3 is times everything in my equation by 3. Okay, my divide by 3 and times by 3 would cancel each other out. So if I times everything by 3 on this side, I get x minus 3 times 6 is 18. 3 times x is 3x. So I've multiplied everything by 3, and it's just because it's the inverse of divide by 3, they basically cancel each other out. So I'm left with x minus 18 equals 3x. I need to solve this. I want my x's to be positive, and I've got 3 of them over here and 1 of them here. I can take 1x away from both sides, and they would still be positive, and it would be 2x. So let's take away x, and that leaves me minus 18, and take away x, that leaves me 2x. Now I've got 2x equals minus 18, but I only want 1x. So I'm going to divide both sides by 2. And I'm left with x equals minus 9. If you want to, you could rewrite that as x equals minus 9, just so it looks a bit nicer. Okay, example 3. Input, take away 9, then times by 4, and then I get my output. So let's write this down. So my input is x. I'm going to take away 9, and then I'm going to multiply everything by 4. So if I'm going to multiply everything by 4, I'm going to put it in brackets first, and I'm timesing by 4. Okay, so I've got 4 lots of my input take away 9. And that's what this says, 4 lots of my input take away 9. We know it's equal to the output, so we put an x over there. Now I've got my equation and I can solve it. The first step here would be to expand the brackets. So I've got 4 lots of x, 4 times x is 4x, and 4 times minus 9 is minus 36. I haven't done anything to the right hand side, so it's still x. So I expanded the bracket. Right, now I can try and solve this. I can add 36 to both sides, and that gets all the numbers that are on their own over to the right hand side. And I can take away x from both sides because x is smaller than 4x. So let's do one step at a time. Let's add 36 to both sides. And I'm left with 4x equals x plus 36. Then let's take away x from both sides. I'm left with 3x equals 36. And then just to finally solve my equation, I don't want 3x, I want to know what 1x is equal to, so I'm going to divide both sides by 3. And there is my answer. X must be equal to 12. Now, just like in the other examples I've done, if I wanted to check this to make sure that I'd done this right, suppose I got to an answer and I wasn't quite sure, let's quickly pop it into my function machine. So my input is 12. I want my output to be 12 as well. So 12 take away 9 equals 3. So I've got to this stage. Then I times the answer by 4. 3 times 4 equals 12. So yes, my input being 12 gives me an output of being 12. So if you're not sure, always check your answer by quickly putting it into the input, the function machine, and make sure you're getting the desired results. Okay, last question. My input is x, my output is x, and then I do my functions or my operations in between. So I'm taking away 12 first. So x take away 12. Then I'm going to divide it all by 5. It was different to example 2. I divided first by 3. Then I took away 6 to what I had from that. This one's slightly different because I'm subtracting 12 first, then I'm dividing everything by 5. We know this is equal to x. So again, similar to what I did before in example 2, I want to undo this divide by 5 because then I'm not working with a fraction. So I'm going to times both sides by 5. And I've got x minus 12 equals 5x. Now it shouldn't take too long to actually solve this. The smaller amount of x's is x on its own, so I'm going to take away x from both sides. And I'm left with minus 12 equals 4x. I don't want 4 lots of my input, which is what x is. I don't want 4 lots of it, so I'm going to divide both sides by 4. And I get minus 3 equals x, and that is my answer. It's absolutely fine to have negative answers, even decimal answers, or possibly fractional answers. Okay, so don't be put off by your answer. The best way to check to see whether you've done it right is to put your answer into your machine and make sure it works. Okay.